Oh, looky there. There's a bat over there. Hi, bat. How are you? Ow! What was that for? What? Wait, go away. Stop hurting me. Leave me alone. Ah! I don't like this. Oh, boo, you missed me. What's up with that? Oh, stop it. Whoop. Oh, I dodged. You can't get me. Whoop. You can't get me. Oh. Okay, we're going to learn how to do that. Welcome back to LewyT Amusement Academy, Part 19. So, you remember how our bunnies walk around, and I think we can make use of the simple wander script that the bunnies use of randomly moving around. And what if instead of just stopping and staring at us when they get close, they instead attack? So let's make some new scripts, and we're going to start with the simple wander script, and we'll just make some minor changes. We want it to still be useful for the bunnies to wander around and do what they do, but we want our enemy character to also wander around and then switch modes into attack mode if we get close. So here is our simple wander script. So there was a using statement that I didn't do anything. I removed that. I changed these serialized field private variables to public variables so that we can access them from outside this script from another script, and we will. I removed this collider detection sphere. I've realized this was completely unused, and so removing it doesn't break the bunnies, and it's completely not needed. So I think that improvement is a good idea. So I also made a change to this direction to target method on the simple wander script. This method, it just takes your position and another position and calculates the direction to that other position. And it was a private method, and now it is a public static method. Public makes it available from an outside script, but static makes it so you don't have to reference a instance of the script. You don't have to find it as a component on an object to use it. You can just use it from the class. And I have one other little change where if we're in the collider, but this script is disabled, we return. Doesn't do the code in this section. Okay, that's all for this script. Okay, so I know you're wondering, how can we make such minor changes to the script and it still work together with other scripts like this enemy brain? And I will explain that as we go. This is an all new script, so you'll need to create a new model behavior called enemy brain. It just uses system.collections and Unity Engine. It's got several properties on it, but I will just discuss them as I come across them in the rest of the code. So you don't try to understand them out of context. So the first one is in the start method, we are detecting the component for the simple wander script, calling it wanderer, and enemy charge is the enemy charge action script, which is the next script we will get. This way we just got some references to them. And then we have a OnControllerStay. So this will only work if you have a trigger collider. So as long as you're, got something that is entered the collider and every frame it's in the collider, it will run this code. So it is looking for this in combat variable. It's a Boolean. And if it's false, meaning it's not already in combat, and then the item, the object that it is colliding with is of tag player, then it will set the target to this transform, and target is just another variable up there at the top. And then it starts a coroutine called combat sequence, and that is the next word. This is a way to run another method independently of the current one. So you can start a coroutine like this, and it just starts it, and then you could have more stuff after that, and they would run side by side. The other way to start a coroutine is to yield return it, which means you basically wait until that one's done before you continue. So that's what this combat sequence does. First, we need to pass in its my target, which is just the transform of the character that collided with this trigger. We say we are in combat now. That's true. And then we set the wanderer script to enabled false and is traveling equals false. And that way it turns off the wandering behavior and turns on this combat behavior. We yield return this warm-up routine. That is what that does. It will turn around and face the enemy that is trying to attack and wait for a very short period of time. And then the next thing it does is it performs the charge. This is an attack, like a ramming attack. So we're starting a coroutine for enemy charge, and that's this other script, .perform charge, and that's a public method on that script. And we're giving it the position of the character that it's attacking. And the next thing it does after it attacks is it waits for a cooldown time. So that way it just doesn't attack really fast and give you no chance to escape or defend yourself. So it waits for a cooldown time, and then after that, it retreats from the target it's attacking. It runs away for a little distance so that it can ram you again. That's the sequence, and then it turns combat back off and wanderer back on. So that's your basic sequence. Now let's look at what these things do. The warm-up routine, it sets a timeout, and it uses this warm-up time that's one of the variables at the top, and then it starts a while loop, and as long as the timeout is greater than 0, it will keep going through that loop. And what the loop does is it detects the direction to the player. It uses that simple wander dot direction to target, detects that, and then it rotates toward that, but it's doing this over time. Multiple frames will pass through this one method. So it needs to rotate a little bit per frame, and so this is how you do it with the Quaternion.Slerp, and then using time.delta time. And then the timeout is subtracted by time.delta time. That's how much time has passed in this frame, or the last frame maybe. That keeps getting reduced every time it runs through this loop until it is down to 0 or less. And then the last thing it does in the loop, so this happens multiple times, is it yield returns null. And what this does is it just pauses this method for one frame, and then it'll come back to it the next frame. So that's how you can spread a single method across multiple frames. Is you put it in a loop and you put a yield return in there, and it'll just do one iteration of the loop per frame. Yield return null. The next routine is retreat routine. Now, I wanted to mention that this I enumerator is what a coroutine must return. So that's why you see I enumerator. These coroutines have to be set up that way. Retreat routine also needs the transform of the target that you're attacking. It calculates the direction away from the player or from its target. It's its own position minus the target position, and then normalizing that. And then the destination is going to be that its current position plus that away from player direction times the distance that it wants to retreat. And that's a variable at the top. Then we're going to set another timeout. We're going to set this one equal to the retreat timeout, which is another variable at the top. And now we're going into another while loop. And this while loop is going to run as long as the distance to the destination is greater than 0.8. So once it gets to 0.8 or less to its destination, then it will say, we're done. We're close enough to our retreat position. The timeout has to be greater than 0. And again, this timeout is being reduced by time.delta time every frame. So we're going to calculate the direction, and that's going to be the destination minus the transform. Actually, we should be using away from player here. Direction is just going to start off as the direction away from the player, but then we're going to turn it to the Y position as 0. So if you're going uphill or downhill, it doesn't care. It's just trying to go straight away from where target is. And then the target rotation is the direction. That's going to be basically away from the player. And the transform rotation is going to do that same thing. It's going to slurp rotate it, starting with the rotation it's currently rotated, and then the target rotation And then the speed is going to be the turning speed from the wanderer times time at delta time. And then this is the actual movement. We're going to take that, the direction times the movement speed plus a vector 3 dot down. And then this is just the force of gravity, so that if it moves straight away from a player and it's on a hill going downhill, it won't go straight out into the air, but it will follow the ground. Then we're going to use the character controller and a .move statement. We're going to use that movement value and the time.delta time. And then we're going to yield return null. That's basically yielding for one frame. That's inside this loop. And as long as we meet the conditions for that loop, we'll keep doing it. And but once we no longer meet the conditions for the loop, we're done. Now remember, that's either the timeout is reached or the destination is reached. And that's that script. The only thing we have left is the actual charge action itself. Okay, enemy charge action. This is our last script that we're going to work on today. It just needs unit engine and system.collections. It is called enemy charge action or model behavior. You'll need to create that script and copy this code into it. Again, I'm just going to cover these properties and variables when I get to them in the code. So on start, we're going to set this controller to the character controller component of this character. And then we are defining this perform charge. Now, see how it is public, so we can call it from the other script, which we did. And it's an IEnumerator return value because it is a coroutine. And we are sending it the player position. So this really means the target's position that it's attacking. First thing we're going to do is set this Boolean is charging to true. We're going to set the start position as its current position. We're going to set the attack direction, basically calculate it from the player position. That's the target that it's attacking. And its current minus its current position dot normalize. So that's just the vector that points in that direction. And then we're going to set the y to 0. So it doesn't matter if you're going up or downhill. Then we're going to calculate the rotation as equal to the direction that we're going, the attack direction. It will turn exactly toward your attack direction. Now we're going to calculate the target position, and that's the player position, which is our target really, plus the attack direction times the overshoot distance. So overshoot distance is a property at the top. And the reason we want an overshoot is that if you run away while it's coming at you, you want it to try to catch up. It won't change its aim. It will still go in a straight line, whichever direction it was going when it started. But if you run straight away from the this enemy that's attacking you, it will keep coming for at least for a little while. And it may or may not be enough for it to catch up to you and still attack you. So that's why we want to do an overshoot distance. So it doesn't just go where you were and all you have to do is step away 1 pixel and then it doesn't get to you. If you were doing this kind of attack, you would, if you miss, you're going to keep going. Maximum distance we're calculating as just the distance between the start position and the target position. And that way we've got our overshoot distance built into our maximum distance. Just going to be a number. And then now we're going to set our start time as the current time. Time.time is how you find the current time. And now we're going into, this is basically our coroutine while loop. And we're going to say while we are charging, so that's going to start off as true, and the distance between our current position and the start position is less than the max distance. So we're saying we won't charge any further than that max distance. So once we've reached the max distance, we're going to stop even if we didn't hit anything. So that's what that loop condition means. And then when we're inside the loop, the first thing we do is we check for the timeout. And if we've reached the timeout, we're going to jump out. We're going to be done. We could have also built that into the while condition, but it makes it really long and complicated. Simpler here. Now we're going to calculate our move for 1 frame to be the attack direction times the charging speed. The charging speed is set up here at the top, and it's something we can set in the inspector. And then we're going to do the controller.move, that's our character controller. It's a component in Unity. We're going to use that move distance, and we're also going to add the vector3.down gravity, and we're going to multiply it by time.delta time. And then we're going to yield 1 frame. And when we're done with that loop, whether because we reached our maximum distance or we reached our timeout, we're going to exit that loop, and then we'll be done. We'll set is charging back to false. Now, the only thing left is when we actually hit something. So this is a special method that is meant for if you have a character controller. So OnControllerColliderHit is used whenever a character controller actually hits something, and it takes in a hit variable, and that hit variable can be used to detect the character that it's the game object that has the character on it. So if we hit something, this method will be called. And if we are not charging when this happens, then we're going to finish. We're done with this method. So this will happen when it's just walking around in its normal simple wander. It will trigger this method whenever it bumps into stuff. And we don't need it to do anything different because that's already handled in simple wander. But so we'll return if we're not in attack mode. But if we were in attack mode, then we need to get the character component of that object that it hit. And then as long as that character component is not null, because if it hits a tree or a rock, then it's not going to have a character component. And then we're going to say character.damage, the damage amount, and that's a property at the top. So this is where we actually do damage to whatever character that we hit. And then we turn is charging to false. Okay, that's it. That's all the scripting. Okay, now that we have our script set up, we need to set up our enemy now. I'm going to pick a spot somewhere else in the world. Let's go up here on this hill. And so our enemy is going to have the simple wander script, and in order to keep him from being able to just chase us to the ends of the earth, we want him to be associated with a home base. So first I want to set a home base. Okay, so we need to have some kind of an object for the home base, and now there's Simple Nature Pack, which we have previously downloaded. You can use pretty much any object for this. I'm going to go into the prefabs, and I don't know, pick one of these bigger rocks. So I'm just going to drag this rock onto the world, into the ground a little bit, maybe make it a little bigger. That's pretty big. That's okay. And I see it has a sphere collider. Doesn't match the rock quite. So instead, I'm going to remove that, and I'm going to add a mesh collider, just so that when we run into that object, it seems to be where it really is. And we can use convex. I think it runs a little bit smoother like that. It is not a trigger. We're going to run into the edge and stop. So this is our home base. Now we need a actual enemy. Okay, our enemies. I'm going to go back to my favorite level 1 monster pack. I have heard that level 1 monster pack is going to be removed from the Unity asset store. So if you can't get this, then there's so many other options that you can use. So I'm going to go to the prefabs, and I've used everything else in this except for the bat. So I think the bat will be a nice enemy. So I'm going to use the bat yellow. He's a tiny little bat. We have to scale him up to like, I don't know, 10, maybe 40 seems about right. He's pink, so we need to fix the material. I'm going to change it to Universal Render Pipeline, Simple Lit. Now he's just white, so we got to also set the base map, and I need to make sure I get the right one. This bat color 3, I think, is the closest one to what it's supposed to be. Okay, there's our cute little bat. Okay, we need our bat's home base to be set, so we're going to go to the rock and drag it into home base. That's important.
Okay, now remember we need our bat to have a simple wander script on it. So I put that on there, simple wander. We can change these settings, but we also need a character controller. Character controller, that's what makes it be able to move. I'm going to turn on this gizmo so we can see and look. The character controller capsule collider is huge compared to our tiny little bat. So it's way too big. Because we scaled them up 40 times, we almost need to scale this down 40 times. So the radius instead of 0.5 is probably just going to be 0.01. Now that looks close. It's actually big. I want it to be just barely around the body of the bat. So maybe 0.007. That's about right. 0.007, and the height is also way too big, so we'll do like a 0.1 height. Nope, that's still probably too big. Wherever the bottom of that thing is will be where it touches the ground. So let's try 0.01. That's too small, so 0.05, 0.04. I think that's about right. That's basically the physical presence of our bat. Next, we want to add an enemy brain to this bat. So we got enemy brain and enemy charge action. We're going to use both of those. So we'll also add the enemy charge action. So now we got both scripts on our bat. Now we have our bat set up basically the way we need it to be, but I want it to be a prefab. So I'm going to go out of the level 1 monster pack prefabs and go to my NPCs folder. I'm going to drag the bat yellow into my project. I'm going to make it a new original prefab. So there's our bat. Looks like a reasonable bat to me. This bat does not have any animation. I mean, it's got an animator, but it doesn't have an animator controller. So what we want to do is create an animator controller. I'm going to just right click here in the project and create animation animator controller. We're just going to call it bat animator. I'm going to go ahead and put this into the controller of the animator for the bat. There's the bat animator. Now we need to double click on the animator and go to the animator editor. Basically, it doesn't have any active states yet, so we need to right click, create a state. We'll just do empty, and we're going to rename it from new state to flap. So basically, it's nothing special. It is just a flying animation so that our bat looks like it's flying. Now we need to pick the motion, and there's several. So if we just do a search for bat, they will narrow it down. Bat attack, bat damage, bat die, bat idle, bat move. I think idle is fine. It's basically still flying when it's in idle mode. So if you select an animation and you go down to the bottom and open this, if it's not open, you get to see what it is. And so you can see this, the way it will move if you press the play button. You can see there's our animation. That's what it looks like. I'm just going to use the bat idle in my flap state. Okay, we're going to test this out. It's not going to work, but I want you to see what it looks like when it is just a docile bat minding its own business. It's just flying around its home base, just like the simple wander is basically making it do that. It doesn't need anything else. And it will just fly around as if it doesn't know we're there. And the reason it's not attacking us is because it doesn't have a detection collider. So we're going to stop that. We need our bat to have a collider. So it's in our NPCs. One more component we need to do is the collider component. We want a sphere collider that will be a trigger. So we have to checkbox the trigger, and we want this to detect our character and not just like, it doesn't need to attack the rock or the ground. So those are also colliders that would detect if we don't specify the layer. So we want to include the slime layer and exclude everything except the slime layer. And now we'll see if that's everything we need. Okay, I've got my gizmos visible, so I'm gonna zoom out and look at this guy. He's got where is that Where's my sphere collider? Okay, the sphere collider is huge because it's been scaled up relative to, the 40 times that we scaled up the bat. So we need to make it much smaller. So you can do a 0.05, and that's probably too small. That means he won't attack unless you get inside that range. So maybe 0.1, that's pretty big. That way, if you get that close, he'll attack. Okay, and then one more thing that I want to change is looking at his character controller. He's kind of far up off the ground relative to our slime character. So when he attacks, he won't look like he's actually hitting you because he's up above our head. So I want to change the height, and then maybe the Y center can be adjusted a little bit. Now he'll be flying just a little bit above the ground. Okay, our sphere collider 0.1 is actually, that's still a little bit too small. Let's do 0.2. Now that might be too big, but if you get within that range, he sees you and he wants to come attack you. Okay, here we are. We're done with that guy. And I see something else up here on this hill. There's a bat. I wonder if he will be our friend and talk to us. He is hanging around that rock. Hi, bat. How are you? Ow! What was that for?
What? Wait, go away. Stop hurting me. Leave me alone. Ah! I don't like this. Oh, you missed me. What's up with that? Oh, stop it. Ooh, oh, I dodged. You can't get me. Woo! You can't get me. Oh, he lost track of where I was. Uh-oh, he's coming back. I gotta get out of here.
Okay, that's it. Thank you for watching part 19 of LewyT Amusement Academy. Next time, we will do something simpler and quicker. We will make an enemy hurt itself when it misses you and hits an obstacle. This will be the first thing we can actually do to hurt an enemy.